the properties of gases? Anybody from the class? Yes.
Mass, volume, temperature.
Okay. So we have mass, volume, temperature, and pressure. So those are the 4 properties of gases. Then, when we say mass, what does it mean? That is the space occupied by an object. And then what about the temperature? Okay, stand up. That is the hotness and the coldness of an object. So, and then also the pressure. So these are the 4 properties of gases. Before I'm going to proceed, I want you to see this video.
Gases, unlike liquids and solids, have a lot of empty space between the particles. This makes them compressible because the amount of space between them can be reduced when the volume of their container is reduced. Compressibility is the measure of how much the volume of matter decreases under pressure. Again, that distance can be changed, and there are several factors that affect it. The pressure of a gas can be changed by adding or removing moles of particles, changing the volume of the container, or changing the temperature. Let's see how each of these works. The particles are moving around, hitting surfaces, and creating pressure. When you add more moles of a gas, there are more particles hitting surfaces, and the pressure increases. In this container, the only thing that will change is the volume. When we cut the volume in half, from 1 liter to half a liter, the pressure will double. Temperature is actually a measure of the kinetic energy, or movement, of the particles. When we add heat, we increase the kinetic energy, causing more collisions and raising the pressure. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter at SciencePet.
As the volume, the temperature, then also the pressure sometimes changes. Not just like in, if you're going to increase the volume of a gas, what happened to its temperature? Volume and temperature. Okay, decreases. What about the volume and its pressure? Based on Boyle's law. Okay, so because the Boyle's law states that the volume and the pressure of a gas at constant temperature is inversely proportional. Before I'm going to discuss the kinetic molecular theory, I want you to perform this very simple experiment. Get your glass and also the plastic. So this is what are you going to do. Glass into the water upside down. Everybody do it. Okay, and observe. Put the glass into the water upside down. And observe. Okay, upside down, place it, and then observe what happened to the level of the water. Okay, just observe. Later, I will ask you some questions regarding that activity. Next, lift the glass up, but without the rim going above the surface of the water. Observe what happens. Again, lift the glass up, but take note, without the rim going above the surface of the water. Without the rim going up above the surface of the water, and then observe what happens. Are you done? Everybody observe? Okay, now this is now the questions. What happened to the level of the water inside the glass? Okay, stand up. What is your answer? Belmonte. What happened to the level of the water inside the glass?
The level of the water inside the glass
Increases. So the water level increases. What about this group? What happened to the level of the water inside that glass or inside that plastic? Phenol. What happened? Stand up. So the level of the water increases. So what about this group? The same observation? Okay. Now, next question. What caused this to happen? Why is it that the water level increases? What caused this to happen? Okay, Diliusa. What is your idea? Why is it that the water level increases? What caused that to happen? Because of the pressure inside the glass. Okay, very good. Any other? Why is it that the water level increases? Damilis. Why? The water level increases. So, what caused that to happen? Or what caused this to happen?
As the bottle is put upside down into the water level inside the cup increases because of the air pressure created from inside the cup, and as well as its contact with the water, it it absorbs water coming from its surroundings, which is the water from the bowl.
Okay, very good. What about this group?
Same answer.
Huh? Same answer? Now, class, that glass, it has gas or air inside of it, diba? Oh. And then, once you put that glass to the water, so the glass or the gas inside that glass added to the molecules of that water. So that is why the water level increases. Next, if the rim of the glass was raised above the surface of the water, what might have happened? Again, if the rim of the glass was raised above the surface of the water, what might happen? What might happen if the rim of the glass was raised? Okay, Garcia. The great. If the rim of the glass was raised above the surface of the water, what might have happened? The level of the water decreases. Okay? Yes, Olga?
As we lift the glass above the water, the level of the water decreases because of the pressure and also the molecules we applied earlier, and the molecules above the level of the water.
So the molecules above
The molecules in the water.
the molecules in the water remove. Anybody? Yes, that group. Pelicano.
As we raise the glass into the airway, it will go back to its original form or the normal state of the water.
So it's go back to its original form or the normal state of the water. Now, class, If the glass is raised without leaving the water, or if the glass is totally removed from the water, the volume of the gas is also reduced, causing a decrease in the level of the water. That is because of the volume of the gas was removed, and that caused why the level of the water decreases. So, I'm going to discuss here the kinetic molecular theory. Okay, so that you will understand further what is really mean by this word, the kinetic molecular theory. Okay, first one, kindly read.
Gases are composed of molecules. The distances from molecule to molecule are far greater than the molecule's dimensions. These molecules can be considered as spherical bodies which possess negligible mass and volume.
Okay, gases are composed of molecules. So, that glass, it has molecules. Because it has gases inside of that glass. So the distances from the molecule to the molecule are far or are greater than the molecule's dimension. So just like here, this classroom is filled with air and we cannot see it, right? Because gases are invisible, but you can notice it because you can feel. Okay, you can feel it. So the distances from the molecule to the molecule are far greater than the molecule's dimensions. That is why when you insert the glass to the water, water has molecules, right?
Yes.
And then the air inside the glass has also molecules. So once you put the glass to the water, meaning the molecules from the gases and the molecules of the water, they combine with each other. So that is why the level of the water rises. Then, these molecules can be considered as spherical bodies which possess a negligible mass and volume. Another theory. Number 2, please read. Okay, any other hand? Okay, Agnes.
Gas molecules are always in constant random motion, and they frequently collide with each other and with the walls of the base. Collisions among molecules are perfectly enough that if energy may transfer from liquid to molecule, there's no collision. But the total energy of the molecules is the same.
Yes. Molecules are always in constant random motion. So, constant random motion. Okay, just like our daily experiences at home. Diba? Once you cook a dried fish, even though you cook that dried fish here, so some of your neighbors can smell the odor of that dried fish because the molecules, they are in constant random motion. Once they combine with other molecules of the gas and then mabot si mong ilong, then you can smell its odor. Just like also the perfume, diba? Perfume, the molecules of the perfume spread and then combine with other molecules of gases, so that is, they are in random and constant motion. And they frequently collide with each other, even in the walls of the container. Next, 3. Yes, Buka.
There is negligible attractive or repulsive force between or among gas molecules.
So there is a negligible, attractive, or repulsive force between or among gas molecules. Now, when you say attractive force, what does it mean? Attractive force, meaning they attract or they collide with each other. What about repulsive? Stand up. Repulsive. Stand. Huwag mo, ano? Okay, they do not attract with each other. So, there is a negligible attractive or repulsive force between or among gas molecules. So, meaning, collide. So, there is collision. They either attract or repel from each other. And then, number 4. Yes, Urgine.
Movement of gas molecules is affected by temperature. The average kinetics of the molecules is directly related to the temperature of the gas.
So, movement of gas molecules is affected by the temperature. So, anybody who can give a application of that if the temperature, if the movement of gas molecules is affected by its temperature. Like for example, a fire. Do you have any idea? Okay, Juliusa.
If you burn in the water, the molecules inside the water will move faster.
Okay, then when you boil water, the molecules of the water moves faster because the temperature of the water is increased. And then what happens to the molecules? The molecules are moving fast with each other. And that's the time that the molecules are bouncing back with each other. So, another application. Imata. Ice, okay, ice.
Ice melts.
So the ice melts and from solid becomes liquid, or from that solid, the ice becomes water or ice water. Why? Because the temperature of that ice slow. Okay, slow. So the ice melts. Once you put that ice, like for example here, the table, and then you put that ice here. So what happened to the ice? Of course, the ice melts. What is the reason why the ice melts? Because of its temperature change. Now, there is what we call as the release of temperature. And that is what we call as the exothermic reaction. So the temperature of the ice combined with the temperature in the atmosphere. So that is why the ice melts. Okay, from solid turns to liquid. So those are the 4 kinetic molecular theory of gases. Okay, evaluation. Okay, this is very easy. True or false? Please read number 1.
Gas consists of a collection of small particles traveling in straight line motion and obeying Newton's law.
What is the answer? A gas consists of a collection of small particles traveling in a straight line motion and obeying Newton's law. Yes, what is your answer? Please stand up. What is your answer?
Because it stated earlier that the motion of gas is constant in random.
Very good. Huh? The answer is false. Because states that it is traveling in a straight line. That makes the statement wrong. So, perfectly elastic. And that was explained to the video, no? That the molecules are perfectly elastic. That is, no energy is gained or nor lost during the collision. So, meaning energy is conserved. That is the conservation of energy. Number 4. Number 4. Yes. There are negligible, attractive, or? Yes, the answer is? True. Last. Last. Formulas. Yes. What is the answer? The answer is true. So the average kinetic energy of a molecule is constant. So I hope that you will understand clearly the kinetic molecular theory. So that's all for this afternoon.